We're going to look at a couple more examples that are similar to the problems I just had an example to. So again, if you're feeling pretty comfortable with those ones, if you have a pretty good idea of how the absolute value thing works, you don't have to watch these ones. But if you want to see it again, or really if you just want to try some on your own, see the problem, pause, work out the problem, and check it. It's a really good thing to do. And it's a easy way to check quickly to see if you have the absolute value thing figured out. So these ones will be examples to be. We want to simplify again. First, let's simplify the square root of 32 x to the 4th y to the 6th. And something that you can do other than just thinking about like what squared gives me whatever is to kind of break it down a little bit more like we have done in the past. So 32, for example, is 16 times 2. And we can take the square root of 16 nicely. X to the 4th is x squared times x squared. Y to the 6th is y cubed times y cubed. So both of these, I have an x squared twice. The square root of x squared times x squared would be x squared. That could come out. The square root of 16 is 4, so that comes out too. That comes out. The square root of y cubed times y cubed, we have something times itself, is y cubed. Now since we had an even root, this really should all be in the absolute value. But notice we have this 2 that was left over also. That 2 we couldn't square root, so that's going to stay underneath our radical here. Now let's think about, do we actually need our absolute value here anywhere? Well, if I go term by term, the 4 is always going to be positive. X squared is always positive. Y cubed isn't going to be. So the y cubed needs to be inside of our absolute value, but the 4x squared doesn't need to be. So here's my final answer. 4x squared, absolute value y cubed, square root of 2. Kind of messy looking. Okay, my next one, we'll do a cube root of 27 x to the 8th, y to the 10th. And cube root of 27 is 3. So that works out nicely. X to the 8th is x squared. Sorry. X cubed times x cubed times x squared. So thinking about like how many times does this power go into our 8 here? And then y to the 10th, another way to think of this is y cubed times y cubed times y cubed times y. There's my 3, 6, 9, and my 10th power here. So the cube root of 3 cubed is 3. Cube root of x cubed gives me x, another x. I have x squared out here. This x squared I can't cube root, that's going to be under my radical still. But then I can cube root each one of these guys, y cubed, and y cubed. Cube root of y cubed is y, another y, another y. That last y is left over underneath my radical. And since it's an odd root, I don't need my absolute value anywhere. One last one to look at, is, what if I had the square root? X to the 6th, y to the 8th. X to the 6th, since it's square root, let's think about how many x squareds fit there. Square root again, how many y squareds fit into y to the 8th? Well, the square root of each one of these is x. The square root of each one of these is y. I have 3 of these guys. I have 4 of these guys. It's an even root. So we start off with our absolute value and then think about if we actually need it or not. The x cubed, that could be positive, could be negative, depending on what x is as a number. Y to the 4th, it doesn't matter what y is, it's to an even power, so that's going to be positive. Our y really doesn't need absolute value, just because it's kind of redundant to have it there. So our x needs to be absolute value again. The y does not need to be. And that's my answer. Something else that might kind of just help think about, do we need the absolute value or not, is to think about what this would look like if we actually had numbers. So if I had this again, the square root of x to the 6th, y to the 8th. Let's pretend for a second. We'll let x equal -1. And y equals -2. Let's see what happens. So if I thought of this as x to the 6th, y to the 8th, if I didn't have my absolute value like what we saw before, we'd have x cubed, y to the 4th. Now let's pretend like I didn't need absolute value at all. If x is -1, and I look at my original, I'd have the square root of -1 to the 6th power is going to be +1. -2 to the 8th power is 256. And the square root of 256 is 16. Now, if I didn't have my absolute value in here at all, let's look at what we'd have. X cubed, well, -1 cubed, and -2 to the 4th power. -1 cubed is -1. -2 to the 4th is 16. That would give me -16. So again, kind of as we saw here, our y to the 4th, the -2 to the 4th in this case, we really didn't need it to have the absolute value there because it's going to be positive anyway. But having this absolute value around the x cubed made it so my -1 cubed really was +1, giving us the +16 here, making it match the original. So again, this is just kind of another example of how we actually need the absolute value and how it comes into play.